Hi dear students, today we have come with a new video of class 11. In the previous classes we have started a new chapter, that is motion in straight line, and there we have learned the basic calculus, that is differentiation and integration. Today, using that calculus, we just want to prove the equations of motion. So you have learned about equation of motion in class 9. Three equations of motion you have learned, that is v equals to u plus at, is equals to ut plus half at square, v square equals to u square plus 2as. Okay, and you have proved it by general way and by graphical method. Here the same equations we have to prove by the help of calculus. Let's see. So first we want to prove the equation number 1, that is v equals to u plus at. That is our equation number 1. So here, which equation we have to follow? Which differential equation we have to follow? We all know that the differentiation of velocity with respect to time, that will give us acceleration. Differentiation of velocity with respect to time, that gives us acceleration. So can it be written as like this way, that dv equals to a into dt? Now, if I want to find the velocity here, we have to integrate it. Okay, so by doing integration, we get. Okay, so we are doing that integration, that is integration of dv, that is equals to integration of a dt. Now, for starting any integration, we need limits because we are doing definite integral. So here we have to assume one thing, that at t equals to 0, means whenever we have started the observation, v that is equals to u, means your velocity is equals to u, and at t equals to t, means when the time t you have taken, that time your velocity is equals to v. Okay, so now it is easier to put the limit. Here you see, here it is the change of time, so time is changed from 0 to t. So whenever you have started, the time is 0, and at end the time is t. Whenever you have started, your velocity is u, that is the initial velocity, and at end the final velocity is v. Okay, now do the integration of dv equals to v. It is having to limit u to v, and a is a constant, a will come outside, so integration of dt, that will be t, and it will also having a limit 0 to t, and we know it is upper limit minus lower limit, that is v minus u is equals to a into t minus 0, because here upper limit is t and lower limit is 0. And if I write here v minus u equals to at, or v equals to u plus at. I'm telling that this process comparatively it is easier than the previous process you have done. You see how easier way we can get the equation v equals to u plus at. That is equation number 1. It is proved. Okay. Now we're going for equation number 2. And equation number 2, you all know that. What is it? That is s equals to ut plus half at square. So our next equation is s equals to ut plus half at square. Now whenever we have to see a, then we have to use that differential equation where the s is there. So we all know s is the distance, and we know the differential equation, the differentiation of displacement with respect to time gives us velocity v, right? Differentiation of displacement with respect to time gives us velocity, and from here we can write ds equals to v dt. In this case, we have to use a twist. What is the twist? We know that v equals to u plus at. Just now we have proved it. So in the place of v, we have to put that equation, that is ds equals to u plus at into dt. Okay, and now before doing the s, we have to use one certain condition, that at t equals to 0, when we have started the time, definitely that time no displacement is occurred, so we are assuming that displacement is equals to 0. And at t equals to t means where your time is t. Okay, so here you might be confused that t equals to t means at time t. So here t, it represents the time t, and here it is general representation of time. S equals to S. So S, it is the representation of displacement, and here S, it is the value of the displacement S. Okay, now we integrate it, because by integrating we get, so if I integrate, integration of ds equals to integration of u plus at into dt. Now talking about the limits. So on which thing, based on the limits we have to take. So as it is dt, so here the limits we have to take for time. So time is changed for 0 to t. At time t equals to 0, what is our displacement? Now your displacement is also 0. At your time t, your displacement is s. It is already told. So now integration of ds means s, its limit will be 0 to s. And now we have to make the integration by rule. So we have to break it into two. 0 to 2 u dt plus a dt. 0 to 10. Okay. So here it should be s minus 0, and integration of u, integration of dt, it will come here, plus a should be constant, it will also coming out, integration of dt. Okay, one problem is there, here is at, so it will be t dt. Okay, a into t dt. Now put the limit 0 to t, 0 to t. Coming this side, integration of dt. So here it is s minus 0 means s, u integration of dt means u into t, its limit should be 0 to t, plus a into integration of t dt means integration of x dx, simple thing, it is t square by 2, and limit should be 0 to t. Okay, now put the value u into t minus 0, upper limit minus lower limit, plus a by 2 into t square minus 0 square. Same thing, upper limit minus lower limit. And now your s will come ut plus half a t square. So your equation is proved. Okay, so see the process by which we have got the equation s equals to ut plus half a t square. Okay, now we'll go for the last equation, and that in that equation we have to make a little more tricks. Okay, so what is the last equation? We all know that the last equation is v square equals to u square plus 2as. And now here you see no time is given, there is no time. Then how we can able to find it? How we can able to find the equation? Now in this case also we have to take the equation dv by dt is equals to a, what we have taken in the first equation, that is dv by dt equals to a. Okay, can it be written like this way, that dv by ds into ds by dt equals to a? See what tricks I have taken. dv by dt, that I am just breaking into two way, dv by ds into ds by dt. Okay, so you see ds will be cancelled out, it is dv by dt. Now if this has written that ds by dt means what? ds by dt means v, that we know that ds by dt equals to v. So here we can write v into dv by ds equals to a. v into dv by ds equals to a. Now v dv, we just cross multiply a into ds. We just cross multiply the ds to a. Okay. Now by integrating we get. So here we have to do the integration. So for integration we need a limit. Okay, so what limit we have to take? So here you see two changes we have shown. One there is for velocity and another there is displacement. So we can write when velocity v equals to u, that is initial velocity. Initial velocity means at t equals to 0. Your velocity is u. That time your displacement should be 0 as per the previous assumption we have taken. And when t equals to t, your velocity should be v, that is final velocity, and that time your displacement should be s. Okay. Now you see, now your limit will be easier for given. So integration of v dv equals to integration of a ds, and when your velocity is u, that time your displacement is 0. Okay, because here it is at time t your velocity is at time t equals to 0, your velocity is u and your displacement that should be 0. And when your velocity is v, that time your displacement is s. Okay, so by this way we have to give the limit. So in this step, integration u to v, v dv, integration 0 to s, a ds. So integration of v dv means v square by 2 and its limit will be u to v, where for case of acceleration it is constant, it will come outside. So integration of ds will be s, 0 to s. So if I have done here upper limit minus lower limit, so half will going outside, upper limit v square minus lower limit u square. Okay, v square is there, so it is v square minus u square equals to a into s minus 0. So if 2 is multiplied over there, so we can write v square minus u square equals to twice as, or v square equals to u square plus twice as. So our equation is proved. Keep it in mind, several times this equation is asked to prove in exam. The equation is asked itself to prove it in exam. Okay, I think you have got it. Now we'll go for the last thing. The last thing means one more equation. So you have already told, you have thinking about this, sir. We have already done 3 equations. So apart from this, one more equation is there. It is also one kind of equations of motion, but it is not taken as equations of motion. That is the displacement of a moving body in nth time. Displacement of the moving body in nth time. What is nth time? I am just explaining you. Assume it is told to you that find the displacement of a body in 10 seconds. find the displacement of a body in 10 seconds. If acceleration and initial velocity is given to you, so you will easily write down s equals to ut plus half at square. Okay, so you will put the value of time, you will put the value of initial velocity, acceleration, and you can find the displacement in 10 seconds. But if it is told that you have to find the displacement in 10th second, 10th second means when the 9th second is completed and 10 second is about to complete, in between this period, how much displacement is occurred or how much displacement is happened. Okay, I'm giving you one idea. You see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the time. Okay, so if it is told to you to find out the displacement in 10 seconds, so it is clear that you can able to find the total displacement in 10 seconds. The total displacement in 10 seconds you can able to find. You can also able to find how much displacement is occurred in 9 seconds. So if you minus it, that is displacement in 10 seconds minus displacement in 9 seconds, you can able to find that displacement in 10th second. That last second, how much it is displaced. So in this case also, if I want to find out that displacement of a body in nth time or nth second, so that time we have to find out how much displacement occur in n second minus how much displacement is occurred in n minus 1 second. So if I minus it, I can able to find the equation. Okay, let's go for it and see how it is come. Clear? I think you can able to understand if we do it. In general way also we can do that. Hope you have done it also earlier. But how calculus, by using calculus, how can able to do? Let's see. So again we'll go for same equation, that is ds by dt, that is equals to v. Okay, ds equals to v into dt. That is also so obvious. And we know one thing, that is v equals to u plus at. So we'll replace it, ds equals to u plus at into dt. Now exactly the same thing we have done, what we have done earlier to prove that equation number 2, that is s equals to ut plus half at square. So here also we have done the same thing. So let's see, by integrating we get, now there is a problem, that integration of ds equals to integration of u plus at into dt. Okay, now the limit. Initially, we have taken that limit from 0 to s at time 0 to t. But here, we want to find the displacement in nth time. So, the time should be, so at t equals to n, s equals to sn. Means at time n, displacement should be sn. And at time n minus 1, displacement should be s of n minus 1. Okay, so at time n, displacement should be sn, and at time n minus 1, displacement should be sn minus 1. So we want to find out from n minus 1 to n how much the body displaces. That should be the nth time how much the body displaces. Okay, so the time t, it will be changed from n minus 1 to n, and here the displacement will change from s of n minus 1 to s of n. Now let's do the integration. So integration of ds should be s, its limit should be s of n minus 1 to s of n equals to, if I make it separate, I am doing it directly, just skipping some step. So u integration of dt plus a integration of t dt, it is n minus 1 to n, it is also n minus 1 to n. Okay, we are coming this side. So here we have to put upper limit minus lower limit. So s of n minus s of n minus 1. Okay, and here integration of u dt. So dt means t. So if I take u, so integration of dt means t. So its limit will be n minus 1 to n. And for case of a into t dt, so plus a t dt means t square by 2. So t square by 2 integrate limit n minus 1 to n. Okay, so up to this I think it is clear. Now put the value. So Sn minus Sn minus 1, that will give the displacement in nth time, that we can represent by delta S. Sn minus Sn minus 1, that can be represented by delta S, or we can represent delta Sn, that is displacement in nth time. So put the value u upper limit minus lower limit. Here also, if I have taken a by 2, so upper limit is n square minus n minus 1 whole square. Okay, let's calculate it. Delta is n. So n minus n cancel out, it will be u plus a by 2 n square, and n minus 1 whole square means n square minus 2n plus 1. In delta Sn is equals to u plus a by 2 n square minus n square plus 2n minus 1. So n square minus n square will be cancelled out. At last our equation has come, delta Sn equals to u plus half of a into 2n minus 1. That is our equation, the displacement of a body in nth second or nth time. The displacement of a body in nth time, that can be calculated by this way. Clear? See the process. If anywhere you are feeling any doubt, you can ask me. Now coming to one more part. Okay, so equations, all the equations we have decided to do, we have done it. But for numerical, some more tricks we have to remember. So for numerical, I'll make another video. There I have to do some numerical which seems to be little harder, because easier numericals you have already done in class 9. Okay, so we will do little more harder numerical. One numerical I am going to do here. To tell the truth, that numericals also you have do earlier, but here we have to make you remember one thing. One question has come several times, that if a body covers a distance in two different way, that means in first half it goes with a velocity v1, and in second half it goes with a velocity v2, then what will be the average velocity of the body? It's a very common question. I know that most of you have done it in class 9, but I'm just making you remember a little bit, because from here the questions may come several times. So half of the path of a distance that is covered by a body in a velocity of v1, and half of the part with a velocity of v2, then what will be the average velocity? How we have to find it out? So let total distance equals to 2d. Okay, total distance I have taken 2d. So half path means here d path it will cover by a velocity v1, and here another d path it is covered by a velocity v2. Okay, so why I have taken 2d? Only because of, if I have taken d, we have to use the fraction. So we don't want to use fraction. For that reason I have taken 2t. So find the time taken by the body to cover first half. So how much time it is taken to cover the body in first half? So first half means how much distance? D. What is the velocity? V1. So if the time we have taken T1, so that should be D by V1. Okay. So first taken time by the body, that is T1 equals to D by V1. And now we can write the time taken by the body to cover second half. So it is T2 and T2 equals D by V2. Now it is coming the average velocity. That is average velocity is equals to total displacement by total time. What is the total displacement here? Total displacement is d plus d, that is 2d, and time is t1 plus t2. So we can write 2d by d by v1 plus d by v2. So if I common d, so dd will be cancelled out, 2 by 1 by v1 plus 1 by v2. If I calculate it, it will coming 2 by v2 plus v1 by v1 into v2, or 2 into v1 into v2 by v1 plus v2. That is the average velocity. Why I have done this? Because it is so easier, you have done earlier. Because of this value. The reason is that whenever you going to do this type of numerical, directly if you know the value, that average velocity, if a body goes first half and second half by two different velocity, in that case our average velocity will be 2 into v1 v2 by v1 plus v2. So if we know it earlier, then it is easier for us to calculate. Okay.